Right now, somewhere in Southeast Asia, there's a cargo ship older than most people watching this video. Its paint is fading, its deck is rusted. Its engine was designed when humans had barely landed on the moon. And yet every morning, that ship starts. No touchscreen, no diagnostics menu, no software update. Just steel, fuel, compression, and noise. Meanwhile, somewhere else in the world, a modern container ship worth hundreds of millions of dollars is sitting dead at a dock. Not because the engine exploded, not because the crankshaft snapped, not because the fuel ran out. A sensor failed. That's it. The engine still physically works, the ship still floats, but the computer controlling the engine refuses to trust its own data, so the entire vessel shuts down and waits for a technician with a specialized laptop to arrive. And that raises a very uncomfortable question. How did machines become more advanced, but less capable of surviving the real world? Because this isn't just about ship engines, it's about something bigger. Somewhere along the way, we stopped building machines that could survive bad days, and started building machines that only work under perfect conditions. To understand why old marine engines refuse to die, you have to understand the philosophy behind them. In the 1960s and 70s, companies like Sulzer and MAN weren't designing engines for elegance, they were designing for survival. These ships crossed oceans for weeks at a time. No nearby repair shop, no specialist technician, no emergency support team flying in from Europe. If something broke in the middle of the Indian Ocean, the crew had to fix it themselves. So engineers built engines with one core principle: forgiveness. Everything inside those engines had margin. The bearing clearances were loose by modern standards. The fuel systems were mechanical. The governors relied on springs, flyweights, and physics instead of sensors and software. The engines weren't optimized for perfection. They were optimized for reality. Bad fuel? Keep running. Dirty oil? Keep running. Worn parts? Reduce efficiency a little, but keep running. These machines expected the world to be messy, and because of that, they survived. A mechanic could literally hear problems developing. A strange vibration, a deeper knock, black smoke from the exhaust. The engine communicated through physical behavior. Human intuition was part of the system. You didn't need a laptop, you needed experience, and maybe a wrench. That's why some of these engines are still alive after 50 years. Not because they're technologically superior, but because they were designed to fail gracefully instead of catastrophically. That distinction changes everything. But over the last few decades, the goal of engineering shifted. Fuel became expensive, environmental regulations tightened, shipping companies wanted maximum efficiency, and suddenly, good enough forever was no longer enough. Modern marine diesels became engineering masterpieces. Today's engines use electronic control units, ECUs, that make thousands of calculations every second. Fuel injection timing, turbocharger pressure, valve operation, combustion optimization, everything is controlled with microscopic precision. Modern common rail fuel systems operate at pressures so extreme that older engines would literally tear themselves apart trying to handle them. And within the right operating conditions, these engines are incredible. More power, less fuel, lower emissions, better performance. On paper, modern engines are objectively superior, but there's a catch. Optimization creates fragility. Because the tighter and more precise a system becomes, the smaller its margin for error becomes too. An old diesel engine was like a rugged off-road truck. A modern marine engine is like a Formula One car. Faster, smarter, more efficient, but also far more sensitive. A tiny metal particle that older engines would ignore can destroy a modern bearing. A slight fuel contamination issue can trigger shutdown protections. A sensor drifting by half a degree can confuse the ECU enough to force the engine into limp mode. And once that happens, the crew often can't do anything. Because the engine no longer belongs entirely to the people operating it. It belongs partly to software. And software changes the relationship between humans and machines forever. Here's where the story becomes bigger than ship engines. Old mechanical systems were understandable. You could see them working, touch them, listen to them. If something failed, a skilled engineer could improvise. That's why old cargo ships survive in developing ports. Need a replacement spring? A local machine shop can make one. Fuel pump worn out? Rebuild it. Piston ring damaged? Fabricate another one. The machine was designed around the assumption that humans would adapt. Modern systems are different. Today, the hardware often isn't the real barrier. The software is. There have been real cases where ships remained stranded for weeks over tiny electronic failures. Not because the engine was destroyed, but because nobody had authorization to reset the system. Think about how insane that is. A machine powerful enough to move entire cities' worth of cargo across oceans can become useless because one electronic component stopped communicating properly. And this isn't just happening in shipping. Cars, tractors, aircraft, factories. Modern technology increasingly assumes permanent manufacturer involvement. You don't fully own the machine anymore, you lease access to its intelligence. And the moment support disappears, the machine effectively dies. Not from wear, from dependency. That's the uncomfortable trade-off modern engineering made. We gained optimization, but lost resilience. The real world is unpredictable. Fuel quality changes, maintenance gets delayed, parts wear unevenly, weather becomes brutal. Old marine diesels were built expecting chaos. Modern systems are built expecting control. And that difference determines survival. Imagine two ships crossing the Indian Ocean. On the older vessel, oil quality slowly worsens. The engine runs rough. The crew notices. They compensate. The ship keeps moving. On the newer vessel, a crankshaft position sensor starts sending inconsistent readings. The ECU suddenly can't verify combustion timing. Immediately, alarms trigger. Power reduces. Then the engine shuts itself down to prevent damage. From a purely engineering standpoint, the modern system is correct. It's protecting itself. But from an operational standpoint, the old engine wins. Because an imperfect engine moving slowly is still more useful than a perfect engine that refuses to move at all. And that's the hidden lesson here. Resilience often looks inefficient until the system is stressed. Then resilience becomes everything. For most of human history, tools amplified human capability. A blacksmith understood his hammer, a mechanic understood his engine, a pilot understood his aircraft. But increasingly, modern systems hide their logic behind software layers normal people can't access. Machines no longer explain themselves, they report fault codes. And that changes the role of human beings from operators to permission holders. That's why people feel strangely nostalgic about older technology. Not because old machines were objectively better, they weren't. They leaked oil, burned more fuel, polluted more, required constant maintenance. But they gave humans agency. You could understand them, repair them, save them. Modern systems often don't want to be repaired. They want to be replaced. And maybe that's the real reason those old ship engines are still alive. They were built during an era when engineers expected machines to stay alive for generations, not until the next software cycle. Somewhere tonight, an old marine diesel built half a century ago will start again. The steel will shake. The pistons will move. The exhaust will roar black smoke into the air. And a crew member standing beside it won't need a password to understand what it's saying. That engine will survive not because it's smarter than modern machines, but because it was designed around a simple idea modern engineering sometimes forgets. A machine that tolerates imperfection survives longer than one that demands perfection. Modern engines are technological miracles, but old engines were companions. And maybe that's the difference. The most durable machines in history weren't the most advanced. They were the ones humans could still fix when the world stopped being ideal. If you enjoyed this breakdown, subscribe, because the hidden story behind technology is rarely about the machine itself. It's about the philosophy of the people who built it.